All right, welcome back. This is the back side of your notes for solving three variable systems. This one is considered an application question. So here they've given us 3 points and they've told us that these points are supposed to exist on a parabola. And the question is, can you come up with and write a quadratic equation that would go through these 3 coordinates? The trick is that you're going to solve a 3-variable system. And the hardest part, I guess, at the beginning is recognizing how you're going to set that up. The key is right here. Create 3 equations by plugging in your coordinates x and y to your standard form of your equation. If all 3 of these coordinates live on the same parabola, then when I plug in -5 and 30, or -2 and -3, or 1 and 0, I should have the same equation. I should be making true statements. So we're going to go ahead and plug it into this form where my a and my b and my c, those real number values, are still going to be variable. So I know that I'm supposed to get 30 when I plug in a -5. So I would have a times -5 squared, and I would have b times -5, and then I would have plus c. So what I end up with, if I go ahead and square this out and clean it up, I would have 30 equal to 25a minus 5b and plus c. So that is my first equation of my 3-variable system. And I'm going to go ahead and do this for each of the 3 coordinates. So this coordinate, again, I'm going back into the standard form. I should be getting a -3 when I plug in a -2. So a times -2 squared, b times -2 plus c. If I clean that up, I'll get -3 equal to 4a minus 2b plus c. And then last but not least, it's kind of nice here that they gave us a 0. We've got 1, 0. So I'm supposed to get a 0 when I plug in a times 1 squared, b times 1, and c. So this would come out to be 0 equals a plus b plus c. And these 3 equations right here are the equations for your system. You're not solving for x's and y's. You're solving for those coefficients a and b and your constant c that are going to give you these values. The rest of the problem then is just like the one on the front side. You have a 3-variable, 3-equation system, and you're going to want to take this backwards and work through to eliminate the same variable 2 separate times. Now, the one that jumps out at me as being the easiest to work with would be the c variable, right? Because they all have the same coefficients, not the word, they're constants, right? But it's 1c, 1c, and 1c. So it'll be really easy to eliminate the c variable in any combination of these equations. So I'm going to work with the top equation first. We'll take our 30 equal to 25a minus 5b plus c. And I'm going to go ahead and subtract. Let's do the second equation, right? I'm going to multiply through by -1, and that would give me 3 and minus 4a plus 2b and a minus c. So when I put these together, let's just pop it right here, we will end up with 33 and 21a, and what do I have? Minus 3 times b. So I have eliminated the c variable for 1 pair of equations. And then I'm going to go ahead and do it again. It really doesn't matter the combinations that you choose because they all have that same plus c. So I went ahead and selected, just because they're close to each other, I selected the second and third equations. So I figured it would be easy to look at. We've got -3, 4a minus 2b plus c. And I'm going to go ahead and I'm going to multiply this one through by -1 so that my c's would cancel. So 0 times -1, and then really I'm just going to have minus for all my variables. And I put those 2 together, and I'm left with -3. Right? I'm going to add them together. My c's would cancel, and I would have 3a minus 3b. You could probably even take out a factor of 3 if you really wanted to. So now I have these 2 equations that both have 2 variables in the same system. And I'm going to go ahead and I'm going to combine equations 4 and 5 here, right? We started with 3. We've got 2 more, but they're smaller. And we're going to combine those 2 so that we can get down to 1 variable and solve for that. So the nice thing about these two, right, I have a 3b and a 3b. So let's go ahead and just subtract the second one. We'll go ahead and multiply this one through. If I multiply by -1, then I can recopy this as 33 equals 21a minus 3b. And I'll have sign changes throughout, minus 3a plus 3b. And that allows me to eliminate my b variable. So 36 and 18a gives me an a value. Whoops, I fell off the page. A value equals 2. I can take that back and I can plug it into either of the two equations that I have left. Maybe I go back to equation 5. It's sitting right there. Minus 3. 3 times a would give me 6. Right? It's 3 times 2 minus 3b. So we've got minus 3, 6 minus 3b's, minus 9. I get my constants together, and at the end of it, I'll divide out by -3, and I'll have solved my b equation. I want to go all the way back to the very top of the page and pick one of the three. Any one of them doesn't matter. To me, the last one's the easiest to work with, right? I don't have to do any multiplying. I'm just plugging in, and I'll get a 0. So I'm going to have 0 equals a plus b plus c. Any of the three would work. You'll have 0 equal to 2 plus 3 plus c. So I'm getting a 5. C must equal -5. Now the trick here isn't that I have coordinates, right? The question was, what is the standard form of the parabola that would hit all three of those coordinates? So my answer is to put things back into that standard form, right? The a represents your coefficient on the square term. Your b represents your coefficient on the non-square term. And your c value represented your constant. And so now I've taken 3 points and I've built a parabola that would go through all three of them. It would have a lot of applications when you're talking about data points. Maybe you want to find a parabola of best fit. Anyways, there you go. Come prepared tomorrow in class to work through an activity. We'll practice these together. It just takes some organization. It's not too bad. It's pretty much the same series of steps every time. It's just organizing and sort of getting in the groove here. Thanks for watching.